So we have this question again, and it reads: two particles of masses 0.4 and 0.3 kgs are attached to the ends of a light inextensible string which passes over a smooth pulley. They are held at same level as shown below. The system is released from rest. Find the tension in the string. That's item number 1. Number 2, find the speed of 0.4 kg mass when it has descended 0.7 meters. So here you are asked to calculate the tension and the speed. But there are a few things that we have to know when it comes to connected particles. These are connected particles. So for all connected particles, this is what you have to know. Since they are all connected by the same string, that means the tension affecting these two are the same. So therefore T1 and T2 are going to be the same. Again, since they are all connected by the same string, they are also going to be moving at the same acceleration. Okay? Therefore, we expect acceleration acting on particle number 1 and particle number 2 to be the same. So if we release these things from rest, this one with a bigger mass is going to move first, and it will move downwards, forcing this one with a lighter mass to move again, but upwards. Therefore, they will be moving in the same direction, and the direction of movement will be like this. Nah? So you expect your acceleration to go downwards. This side, your acceleration goes upwards like this. Nah? So this is what you expect on connected particles. Again, we know for a fact that since there is tension there is bound to be weight going downwards. So this one is going to be a weight number what? Let's just say weight number 1. And this one is going to be a weight number 2, like this. Okay, right. So for you now to be able to calculate the tension in the string, you need to know that if you look at this using Newton's law, which says F is equal to ma, let's start with force number 1. So particle number 1 is going to be this one on this side, 0.4 kgs. So for us to be able now to find F, it means the resultant force for particle number 1. We are going to say, since it's resultant, W1 minus T1 will be our F. Why is that so? Because this particle is going to move downward. Therefore, the resultant force, we are going to find it by saying W1 minus T1. Therefore, in place of F, it will be W1 minus T1. And these are going to be equal to ma. But m now, it's mass for particle number 1. So we are going to say m1, meaning to say it's mass for particle number 1, A. Then for particle number 2, this other particle here, F, for us to be able to find the resultant force, since this one we said it's going to move upwards because it's going to be pulled. This one is going to go down, so it will pull this one up. So the direction of movement is going to be upwards for this one. So therefore, the resultant force, which is F, is going to be given by T2 minus W2. So T2 minus W2 is going to give us M2A. Now, when you have these equations now, you can be able to find whatever that you need for as long as you are dealing with these connected particles. So since we do not have much space on our board, I'm going to erase this so that we can create space and make our work to flow very well. Right, since I've said again that these two particles are connected by the same string, therefore they share the same tension. So as a result, T1 is equal to T2. So now I'm going to substitute one of these in place of the other. So using equation 1, you have, okay, let me make T2 subject of the formula. So my T2 is going to be equal to, on this equation, M2A. Okay, so I'm going to take this to the other side, plus W2. So in place of T2, yeah, in place of T1 or T2, I will put this. Why? Because these two tensions, they are the same. So looking at this equation now, which says W1 minus, in place of T1 now, I'm going to put this expression. Why? Because T1 is equal to T2. So I will have M2A plus W2 like this. So that will be W1 minus T1 is going to be equal to M1A like this. Okay, good. So we have, since we have this, let's introduce everything. Let's introduce the negative sign into the bracket. So we have W1 minus M2A minus W2. This is going to be equal to M1A like this. Collecting the like terms, these ones with A on the same side, so you have W1 minus W2. These are going to be equal to M1A plus M2A like this. So since you have W1 and W2, W1, that's weight number 1, and then W2, that's weight number 2, which is 0.4 kgs. Yeah? Not 0.4 kgs per se. If we look again very carefully on our diagram, we had something like this. Nah? Then we say this is our W1 and this is our W2. But we know for the fact that W is equal to mg, isn't it? W is equal to mg. So for W1, m, that's the mass that is given here. Then g is the force due to gravity. So for the sake of this question, let's use g as 10 just to simplify things. But under normal circumstances, g is 9.81. So I'm going to use g as 10. So W1 is going to be what? M1, 0.4 multiplied by 10. That's mg. Okay? M1g. Minus W2 is going to be m 0.3 g. That's 10. Like this. And this is going to be equal to, I'm going to factor out a, since a is existing in both sides. So I will have m1 plus m2 in the bracket. Like this. Yeah? Right. So 0.4 times 10, that's 4. Minus 0.3 times 10, that's 3. This is going to be equal to a bracket m1 plus m2. But again, we have m1 and m2. So just to simplify here, I will have 1. 4 minus 3, that's 1, is equal to a m1, that's 0.4 plus 0.3. So if I punch that, I will have 0.7, right? So 1 will be equal to 0.7 a. So if I divide both sides by 0.7, divide both sides by 0.7, I will have my a as 1 divided by 0.7. 1 divided by 0.7, that's 1.43 newtons. So 1.43 meters per second squared. Remember, this is an acceleration. So this is your acceleration, 1.43 meters per second squared. Now, since you are looking for tension, you have your acceleration now, and this acceleration is going to affect either particle 1 or particle 2. I'm going to erase this part and leave you this equation where we made T2 subject of the formula. So now, T is the same, either T1 or T2, they are all the same. So if you solve for T2, you are also solving for T1. So now, let's substitute the values that we have so that we can be able to find tension and solve part A, item 1, sorry. So you have here M2, that's 0.3, multiplied by A, that's 1.43, plus W2, that will be mg, okay? Mg, which is M2g. M, that's 0.3, g, that's 10. So if you solve this now, that's going to give you your tension. So I have that multiplied by 0.3 plus 3. So I have 3.43 newtons. So 3.43 newtons. So ladies and gentlemen, for item 1, the tension is 3.43 newtons. That's your answer for item 1. Then for item 2, the item 2, which says calculate the speed of 0.4 kg mass when it has descended 0.7 meters. So we know for the fact that when it has descended 0.7 meters, our S, or the displacement, is 0.7 meters. We have quite a lot of things here. You are given A, it's 1.43 meters per second squared. What else do you have? You are also told that the system is released from rest, so that means U is 0. Nah? U, the initial speed, is 0. And they are asking you to calculate the speed when it has descended up to this much. So to solve for that now, since we have S, we have A, we have U, the only formula that can allow us to do so using the equations of motion, it's this formula that says V squared is equal to U squared plus 2AS, where we are looking for V, isn't it? So since we know that U is 0, so we are going to put a 0 here, plus 2. Acceleration, we just found it here. S, it's given from the question like this. So if we punch this on a calculator, we are going to get 2 multiplied by 1.43 multiplied again by 0.7, and we'll have 2.002. But that's V squared. We need V. Therefore, V will be equal to root of 2.002, and that will give us what? Square root of this number. Okay, so it's 1.41 meters per second. So this is the speed. This is the answer for part 2. This is the speed of the 0.4 kg mass when it has descended 0.7 meters. Okay, I hope you guys got something from this. Just let me know if you are having any questions so that I can address them there and there. Thank you.